Swedish NLP Webinar series. As you know, this is a seminar series where we talk about current topics in the field of natural language processing. We try to select topics that are relevant for the Swedish community, and today we really do have one such topic. This seminar series is co-organized by AI Sweden and the RISE, and my name is Magnus Holgen. I will be the moderator here today. I used to be at RISE, but I am now at AI Sweden since 1 week, heading the research on natural language understanding. So we are just starting out an initiative here at AI Sweden to develop, build, and apply really large-scale language models, primarily for the Swedish language, of course, but in extension for the entire Nordic region. And when I say large scale, I mean models that have a parameter count on the order of billions of parameters. So scaling models up is not interesting in itself, at least not for us. But what is interesting are the effects when we start to scale these models up. And this is something that we will be talking about today. Now, building this type of really large-scale language models, that's not something that we do by ourselves. It's really a highly collaborative effort, and we work together with several different partners in this initiative. For example, the WASP Research Arena for Media and Language. We work together with data providers like KB Lab, and also hardware providers like NVIDIA, and of course, our research partners like RISE. And we're just starting out this initiative, but even so, we have already produced a first version of a GPT model for Swedish, which we call GPT-SWE, of course. And keep in mind, this is not a finalized product. It's a first initial prototype. And we will be talking about how we built it, some challenges and solutions that we have come up with. And then we're going to see some examples of what the model can actually do. So with us here today, we have 3 excellent speakers. We have Ariel Ekgren, who is a transformer expert. He's also a researcher currently at RISE, but he will be joining AI Sweden in January. Then we have Evangelia Gogoulou, who is a language model expert, currently working as a researcher at RISE and also a PhD student at KTH. And then lastly, we have Alice Heiman, who is a genius and affiliated with our team here at AI Sweden. She's also at Victor Rydberg's Gymnasium and a medalist in several international youth science competitions. So with that, I will leave the word to Ariel, but first some practical matters. So during the presentation, for those of you online, you can write questions in the chat, and I will keep an eye open for the chat window. After the presentation, we will have plenty of time for discussions and comments, and we will start with the questions in the chat. We will then go to our physical space out here in the office and take questions and comments, and then I will open up for you online. And just raise your hand or turn on your camera and scream, and I will give you the word then. And we encourage active participation, so if you're going to pose a question, do it in person, preferably. So I think that's it. And with that, I leave the word to Ariel.
Hi, everyone. So let me just share my screen. And here we go. So happy to present the GPT-SWE model. So my name is Ariel Ekgren, and I got an excellent introduction from Magnus, and I'll start the presentation. So first, we'll talk about the model in general. Then we will go into data training and end with some prompting and examples. So what is GPT-SWE? It's a 3.5 billion parameter transformer model trained simply to predict the next word in 100 gigabytes of Swedish text. 1 second, let me make sure I can see my own slides. There. And to put this in perspective, it is more than twice the size of the largest GPT-2 model OpenAI trained. So if you're familiar with that, it was a model that got quite some uppmärksamhet in 2019, and they didn't release that model because they were concerned about the usage. But since then, they have released a model that's named GPT-3 that is quite a bit bigger. And to our knowledge, this is the largest generative model trained on Swedish to date. But in our case as well, due to some concerns about potential misuse and other factors, we are not releasing our trained model at this time. And the team that trained the model consisted of Amare Kuba Gyllensten, Evangelia, Gogoulou, me, and Magnus. And we want to say a special thanks to Mark Abrahams, Ian CCS, Berzelius, Nvidia, Rise, and AI Sweden. Really a lot of partners involved in this. So I will start with a little poem here. So with the model got the initial prompt, utdrag ur prisad diktsamling. And the answer, or the continuation that the model did was: blicken upp mot skyn, mot solen, mot månen, som i ett purpurstoft till en kristallklar dränkande slöja. Och den himmelska synen av din älskade högt upp i det blå. Våren är kommen till jorden och snart ska man göra sig redo att möta sommaren. Vårdagjämningen är här. Det är en högtid, en fest av hopp och tro. Det är ett nytt liv. By GPT-SWE. So it's just an example text, but as you the people who know Swedish can see, it's quite coherent Swedish. And are we sure this is just not a fantastic poem on the internet? Well, at least if you Google this, you get the answer. It looks like there aren't many great matches for your search. So I can't find this fantastic poem outside of what our model has generated. So why are we interested in generative models? So with the traditional approach that we have just arrived at in the last couple of years, in order to use machine learning for a new language task, you have to hand label a new data set, which is time consuming and costs a lot of money. And then you have to fine tune a pre-trained model on this new data set. And then you have to have experts at machine learning that can do that work. And you have to have hardware, of course. But with large generative models, we can, to some extent, forego this process. So we can solve a lot of the same tasks in something called a zero or a few shot manner. And that basically means just write the instructions to the model and hope that it can understand what you have written and give you an answer that corresponds to what you would have otherwise fine-tuned the model to do. And how these models are trained is by next step prediction. And that is probably something that you are all familiar with when you have used your cell phone to write a text message. So you get a suggestion for the next word. So it's not a new thing at all, but the magic with these models is in the scale and the context. And so when you have a really good next step prediction model that is really good at guessing the next word, if you write instructions in natural language, the most likely next word will be something that can really solve your task or produce text that is really coherent. And GPT-SWE is also a transformer model. And the transformer was first proposed in 2017 and has taken the world by storm since then. As Andrei Karpathy just tweeted, he is the lead AI scientist at Tesla, and he's currently building the self-driving cars. He tweeted, the ongoing consolidation in AI is incredible. And what he is referring to with this tweet is the transformer architecture. So it turns out that it's a really general architecture that can handle a lot of different use cases in machine learning and AI. So, I'll go into a very short and high-level history of transformers. So before we had transformers, and especially in natural language processing, we used to train one model per task. If you wanted to do named entity recognition, you used to do a lot of handcrafting, coming up with rules, and then you had a model that you trained for that specific task. If you then wanted to do something else, like sentiment analysis, you would train a model on a sentiment analysis task. You would only train it on the data set that was created for that task. But then enter transformers. And this guy. So the original transformer architecture came in 2017, but some time later, this guy who is named Bert from the Muppets entered the room. And Bert is a transformer model from Google that really got good results on a lot of tasks. And what they did was that they pre-trained the Bert model on a lot of data, on Wikipedia and a lot of web data. And then you could use that same model for a lot of other different tasks by fine-tuning it. And in this little illustration, I mean, there you can see that there is a lot of other Muppets. And after Bert, there came a lot of different variations of this model. The transformer model and the Bert one in specific. But we also, so the BERT models, they can't generate language. They perform, when pre-training, they perform a task that is, you're masking words, you're hiding words, and they're supposed to guess the word in context, but that is not very suitable for generative tasks. But we also have the transformer model of GPT, the GPT family. And there you pre-train, and you don't have to fine-tune. You can fine-tune, but you don't have to. But in order for the model to know enough about language to be able to produce coherent language and solve tasks, you really need to scale up the model size and the data size that you train on. So if you don't fine-tune, how do you evaluate your models, and how do you make sure that they know stuff? There are two ways. The most straightforward way is to look how well does the model predict the next word in your corpora, in your text data. But that is not very instructive with regards to specific tasks. So then, of course, we have a lot of fine-tuning data sets that are made for the BERT variety of the model, but you can often reformulate them and take the data and make it so that it's in natural language. And then you can also see if the GPT model will predict the correct word with regards to your data set. And so coming back to the scaling, there is a lot of indications that what you really need at this point in order to get really high performing and general natural language models is just to make them bigger with respect to parameters and to data. And there is an excellent paper from OpenAI where they basically try to train a lot of different model sizes and show that they just perform better the bigger they get. And looking to the future, we enter an era of general purpose natural language text models. And I want to cite the CEO of OpenAI. In a world where you can talk to a computer and get the output that would normally require you to hire world experts back immediately for almost no money, think about what is possible there. So basically, we're entering really exciting times if we are managing to scale up these models with regards to the tasks that they can automate and solve. So with that said, let's hear more about our training and get some more details. I'll leave over to Evie.
Thank you very much. So let me share my screen. Yes, great. So now that Ariel has done a very good wrap-up of the GPT model, now we will dive into the details of how we trained the GPT-SWE model. So in order to train a GPT model, we need three things. We need data, actually lots of data in the scale of hundreds of gigabytes. We need compute, and more specifically, many GPUs. But we also need a training we also need a training framework that supports efficient training on a multi-GPU system. But first, it's time to go into the data. So we need lots of data in terms of quantity, as I said, hundreds of gigabytes, but we also need data of various sources. And the sources needs to differ in terms of the type of language used, for example, official language or everyday language, and also the domain, as for example, medical data, legal data, or just social media. However, there are not many Swedish curated datasets out of the box that are suitable for large-scale training, today at least. So now this brings us to the challenge that we need to manually collect and pre-process data sources in order to start training our model. So after lots of hours of collecting data, we managed to collect around 100 gigabytes of Swedish text. And this includes existing datasets, for example, OSCAR, the Swedish part of the European Parliament, public state documents. In addition to that, we scraped manually Wikipedia, Swedish Literature Bank, parliamentary debates, and all of these are quite high quality sources for Swedish text. And last but not least, we scraped various Swedish forums and news sources. So here we can see a breakdown of our corpus, and with the green color, we see the data sets with the bigger sizes, and with the red color, we see the smaller data sets. And in this case, also the color is a correlation with the quality of the data. For example, the text in web data or in Swedish forums is less much quality than, for example, Wikipedia or FAS, which is the medical documentation. So as we can see overall, our model is mostly trained on web data, which of course can cause potential risk of misusing the model. And this supports our decision to not release the model, at least for now. Another thing that is very interesting is that if you see here in this red area down in the downside of the figure, this corresponds to the high quality data sources, which is actually not much. So actually this means that collecting high quality data is a real issue, and this becomes even a bigger challenge if one wants to scale the model even further. So now that we have collected 100 gigabytes of data, are we done and we can start training? Not really, because we need to do pre-processing and prepare the data for the model. Cleaning, which means removing spam, HTML tags, and general text not written by humans. Additionally, we need to deduplicate, which means essentially to remove multiple occurrences of the same or almost the same text string. And these two things are really important in order to train a model to convergence and be successful with that. So now we have decided with the data and everything is done, and it's time to decide on the model size. And of course, the goal is to train a model that is big enough to learn our corpus, but at the same time, we want to train a model that is able to fit on a GPU after training so that we can use it for inference. So after consulting a research publication by NVIDIA, which correlates the model parameters with the parameters for training on a distributed system, we decided to train a model that is 3.6 billion parameters and has 30 transformer layers and 32 attention heads. So, of course, in order to train such a big model, it's not possible to do it on only one GPU. And we were lucky enough to have access to Brazil's SuperPod, which is the fastest and which is the fastest supercomputer in Sweden right now, and has 60 DGX servers, and each of that has 8 GPUs. And in order to utilize Berzelius to the maximum, we used Megatron, which is a framework provided by NVIDIA that supports efficient training of large-scale models. And this is done through different types of parallelism, which basically define how the data or the model parameters are split between the GPUs. And I will go through the different types of parallelism down here. So to the left side, we have data parallelism, which is the simplest one, even supported by Hugging Face for training, let's say, smaller models. And in this case, each GPU has the whole copy of the model and then trains the model on a part of the data set. Then we have tensor parallelism, where each GPU sees the whole data set, but then trains only a part of the model parameters. And last but not least, we have pipeline parallelism, where each GPU sees only a number of layers of the model and trains them on the whole data set. And this can be, for example, a number of transformer layers in the case of a GPT model. So a bit more details on the training of our model. We train our model to convergence, which is really important if we want to have a good quality model. And for this, we needed 2.5 days. And in total, we used 128 GPUs. But surprisingly enough, this equals to over 4,500 GPU hours. So it's actually quite many of teraflops. And here on the left side, we can see the training loss, and we see that it smoothly goes down. However, if one wants to scale the training in terms of model size and data size, actually training a model to convergence can be much, much harder. So now we have the model. And how do we know if it's any good? Well, we need to evaluate it. However, there are not many standardized evaluation benchmarks in Swedish at the moment, and we're all waiting for the superlim. So this leaves us with the only choice of manual evaluation, which means playing around with the model, testing different inputs, and inspecting the quality of the generated text. So now I'm going to hear Alice, that's going to present some examples of text generated by GPT-SWE. Off to Alice.
Thank you so much. So I'll share my screen. All right. So yeah, now we have this model, and the question is, how can we use it? And as we saw previously, GPT-SWE is a form of generative model. So you provide it with text, and it will keep on generating text. So you can imagine that if we input different kinds of text, we will get different types of answers. And this is exactly what prompting is all about. Prompting is about giving the model a series of texts or a text input so that we get the model to do what we want. And this is kind of a new type of programming paradigm where we have moved from giving explicit instructions to giving then instructions in natural language. So in the beginning, we might have the traditional programming of what we call software 1.0, is when we have hard-coded algorithms with explicit instructions. And then with the rise of neural networks, we have gone into the software 2.0, where we have programs who are able to learn by themselves through optimization. But now this is a type of software 3.0, where we start with a single model or a single program, and then we use prompt engineering in designing these initial prompts to make the single program specialized to do different types of tasks. And it's kind of, so if we say that we have GPT-SWE and it's trained on all of these, gigabytes of data, what we do is that we kind of use the prompting as a flashlight, and we use it to probe the model. So we say that, okay, we want to access this part of the model or this part of the model. And in this way, we can then use the same pre-trained model to perform all these different tasks. And how do we design these prompts then? So this is an example adapted from OpenAI, and it's a form of sentiment classifier. And the structure of a prompt is usually that you want to first show and tell the model what you want it to do. So for example, you might have this beginning sentence that says, this is a tweet sentiment classifier. So in plain natural language, state what the model is supposed to do. Then we provide few examples. So this is what we call or refer to as few-shot learning, that we provide it with some examples to make the model understand what it's supposed to do. So for example, we might say, tweet, my day has been great. We can use emojis and we can use text. Or maybe, and then say what's the correct label to this sentence or to this tweet. And then we can give it more examples and, for example, say, I don't like this, and the sentiment is negative. And then the last step is to provide the actual task, what we want it to do. So for example, this might be the tweet that we actually want to classify. I love the new Batman movie. And then we'll leave it open-ended. So we just say sentiment, and then let the model keep on generating. And as it has then learned the structure, so the most probable answer will be maybe then positive. So then we can make the model and use it to perform these kinds of tasks. And we also have some settings that we can play around with. For example, there's something called temperature and top P that determines how deterministic the model is, that we can experiment and use to get different outcomes. So we have done some small experiments with the model so far, and what are the results? So all the text that's in regular font will be the human prompt, what we have inputted into the model. And then the bold text, that's what the model has actually generated by itself. So we started with the task of translation from Swedish to English. So here we provided some examples, and these are some samples of what it was able to do. And we actually saw that it was able to perform some basic and complex translations. For example, we can ask, var ligger flygplatsen? And it correctly responds with, where is the airport? Or we can ask it, när är det middag? And it answers, when is it dinner? But sometimes it has some grammar issues when it does the direct translation. For example, jag slutar skolan vid 3:30, and it says I'm leaving school at 4:30 instead of 3:30. And sometimes it goes on to actually responding to the question instead of translating the question, but it does it in English. So we kind of half right, but it's instead of like translating that I feel good today, like how do you feel today, the question, it starts to answer like, oh, I actually feel good today. We also then tried with some more complex translations. And we go back here. So some complex translations. And it actually did pretty well with, for example, black holes, and able to translate with some commas. And it says that black hole is according to the general relativity, a concentration of mass of a strong gravitational force, and so on. And also the same thing here, that it is able to translate this text to the performance has enough simplicity to function as psychological thrillers, and it has enough layers to give new insights. So some tweaks still be able to do. All right, then we also tried with generating lists, for example. So as it is a generative model, it's really good at providing more and more examples. So you can have lists of ideas, or maybe you want lists of, in this case, items to bring on a hiking trip. So we provided with first a little introductory statement that we're going on a hiking trip and we need to prepare. And then we provided 7 examples of the items that we wanted to bring, and then let the model keep on generating items that might be good to bring. And as we can see, it actually provides some very reasonable items to bring on a hiking trip, like a water bottle, maybe a coat, a hat, maybe a knife. And the interesting thing to take away is also that even if you don't have any examples in the beginning, it can still actually generate some pretty useful stuff. So in the beginning, we had the packing list with maybe 10 items. And then we asked it to generate 10 good hiking routes without giving any examples of hiking routes. And we can see that these first 5 or 4 are not really hiking routes, but more links where you can find hiking routes. But then it starts to give actual hiking routes, even though we didn't need to give some examples of hiking routes before. So it has learned the structure from the previous packing list and can use it then in the next one. It also managed to give more explanations to these lists as well. So instead of just stating 1 till 10 items and no more, it could also give descriptions. So here we asked it to give us 10 tips to think about before we go on the hiking trip. And it gives first the list and some contexts. So for example, first off, plan your hike. It's very important to plan your hike. And then 2, pick the right hiking spot or hiking route. And 3, bring enough food, and then some context to it. So it can provide also not only the list, but also more context and information. Moving on to the next thing, we also have chatting. So you can have discussions. And we see this as a potential for maybe language learning, that you can have a space to communicate with a model, and then you can maybe learn language and acquire language. And it's also able to answer some questions. And here we had the kind of a chat between an AI assistant and a human. And the human asks some questions. How can I, for example, how can I come over my fear of speaking in public? Or how can I start training? And the AI starts giving some responses. And what's really important to take away from these chat experiments is that the initial prompt really sets the tone. So in this case, we're really explicit in the beginning to say that this is a conversation with an AI assistant. The assistant is helpful, it's creative, it's wise, and it's very kind. So we're kind of giving the attributes we want the model to have when we're doing the chat. But you might imagine that if we say the model, this is in the conversation with an AI assistant, the assistant is not helpful or it's angry, it will also pick on those traits. So it really shows the importance for us as researchers to design these prompts and use prompt engineering to our advantage to get the model to do what we want it to do. Okay, and then some other fun stuff. I managed to get it to do effective product promotion. So I came up with the hairspray Lokar and wanted it to, make some promotion for this hairspray. I needed some help, so GPT-SWE came into the rescue. So I gave it that Lokar is a revolutionizing hairspray from organic materials, make your hair shines in at least 18 hours. And then the GPT-SWE continues to give some good promotion for this product. It says it's in 4 different flavors or different scents, like the lemon, vanilla, strawberry, and yuzu, very fancy. And it also has a unique formula that makes it absorbing quickly and it makes it very soft and shiny. And also with this list, you can kind of combine it here. And we prompted it then with saying, see what our customers say about Lokar. And that it says that, everyone loves Lokar. It's very easy to apply. So you can get it to generate some really fun stuff. And of course, as Christmas is around the corner, we also tried to generate some song lyrics. So we had the initial prompt was Christmas is here, or Julen är här, by Tommy Körberg. And then we managed to then generate some more Christmas songs. So this is the Christmas song then by GPT-SWE. So we have the chorus, I wish you all a very Merry Christmas. Take care of each other. Be kind to each other. Make sure the children are well. Let the children play. Give them a hug. Savor lovely, that we're worth having a great time. Let them feel that Christmas is good. Merry Christmas. A very nice Christmas message from GPT-SWE. And on the same note, we also tried writing speeches with GPT-SWE. So every year, the King of Sweden holds his annual Christmas speech. And he always begins with the same first line. Kära svenskar, hemma utomlands, alla I Sverige. And then he keeps on going. And what we did was we inputted the 2018 speech, the first 3 paragraphs, and then let the model continue to generate. And it generated 5 paragraphs and also an ending. So here is one of the paragraphs. And then it came with the ending here. So this is the original, but I can read the English one. So this is what GPT-SWE then generated as a speech. We all have a responsibility for how we treat each other and our surroundings. We all have a responsibility for how we take care of our Earth and our climate. We all have a responsibility to show compassion and empathy. We all have a responsibility to stand up for the values that support our society, regardless of whether we were born in Sweden or have moved here for the sake of love or freedom. I wish you and everyone else a peaceful Christmas weekend filled with love, care, and warmth. Merry Christmas and a Happy New Year. It even added a little applause for itself, which I thought was really nice. Okay, so those are the first experiments that we've been doing with the GPT-SWE, but of course we're looking into the future and all the other possibilities that you can do. We're working with taking more qualitative but also quantitative experiments to probe what the knowledge can, what the GPT can do and what knowledge it has, but also doing further experiments with assessing when the model works and when it breaks down, and know what we need to avoid and how we, working with the model to make it function. And of course, further applications, what can we use it to do, and hopefully also have a larger model in the future to improve the quality. So yeah, that's everything for now.